Thank you, Kevin. I appreciate a couple things about our speakers. I like the safety messages, always very helpful and keep us focused on safety. The other thing that I appreciate is the speakers' sensitivity to our schedule. I was thinking maybe I'd have to bring in, orchestra music or something to ease people off the podium like they do on the Oscars. But I appreciate that on behalf of our speakers. Our next discussion is by Josh Wagnaar, a senior engineer from Southern Company. And he's going to talk about the implementation of natural gas capability to existing coal boilers. We've heard a lot today about one of the building blocks for the Clean Power Plan being fuel switching or coal to gas conversions. I tend to think that this is the proverbial solution button. Sort of hit the button and you got all this conversion. So I'm looking forward to hearing Josh talk about what all of that involves.
Good afternoon. I'm Josh Wagnaar, representing Southern Company, and I guess I'm here to go over some of the projects I've been involved with, switching some of our existing boilers to firing some natural gas. A little bit about our company. We operate with retail or regulated operating companies in the Southeast, and we have a wholesale generation operating company that expands through the U.S. We have about 4.5 million customers, and we have a capacity of over 46,000 megawatts. And so the coal to gas, the gas additions that we're going to talk about are adding, cover about 2,200 of those megawatts. We heard a lot earlier about fuel diversity, and we try to maintain some pretty diverse resources. We operate with about 40% coal, 40% natural gas, and 16% nuclear. And we've got a few exciting projects that we've been working on. We've got 2 new nuclear reactors that are coming in at our plant in Vogel near Augusta, Georgia. And we have our Kemper County IGCC facility that will be our new coal plant. That'll be our new coal plant. They're gasifying lignite coal. And so I guess we've been talking a lot about the clean power plan, but I guess the primary driver for why we're switching those units was MATS. And so with MATS, the natural gas inherently lowers the emissions targets, that the pollutants that MATS was trying to do. So natural gas units are exempt. And also there's one caveat that allows you to keep coal as a backup. And so that's important for reliability issues, in case natural gas has some sort of supply issues or anything. We do have at one of our plants the capability of having coal actually as a backup on a very limited basis. So here are the 3 plants that we're converting. It covers 8 units and approximately 2,200 megawatts. I guess the demographics of the units is they're fairly medium to small units, all over 40 years old. And I guess but design-wise, they're designed, got some fairly different designs. Whereas at Gaston, we have 4 B&W wall-fired units that's the plant that's going to maintain the coal backup. And I guess the selection for the coal backup really depends on if you have other units at that plant that are going to be using coal. So then it makes sense that you already have coal there, you can have coal as a backup. At the other 2 plants, there won't be any other coal units there, so keeping coal didn't necessarily make sense. At our Greene County facility, we have 1 B&W unit and 1 Raleigh Power unit, so we've got 2 fairly different units there to try to design to. And our plant Yates and Georgia Power are 2 combustion engineering tangential fired units, which makes them different. I guess in addition to the ones that were current projects, we already had some units that were firing natural gas, and due to MATS, they actually have the coal capability removed. And so that covers 4 units. So I guess our schedule here, we're about halfway through our gas additions. And so we're currently working 6 of the 8 units requested and were granted the 1-year extension. So we're looking at the April 2016 deadline to get all those finished. Whoops, jumping ahead. All right, so I guess in the end, what are the changes that need to be made, or what does it take to design one of these units to switch to gas? And for one, it takes a lot of piping and a lot of valves. If you look at the top left picture there, shows a model shot with all the orange is new gas piping that had to be added to the unit. So it's a pretty substantial amount of gas. It also takes a gas pipeline. So 2 of the plants we already had gas already supplied to the plant, but one of them didn't. So we had a 32-mile pipeline we had to build. And so when you start having to add pipelines, it starts increasing cost and starts making things less economic. It takes a lot of work to rework your gas yard, your gas conditioning facility to make sure your regulators are in proper use. It takes some burner modifications. If you look at the bottom left there shows a T-fired unit where the gas is added and the coal has been removed. And the bottom middle shows a wall-fired unit that has the coal capability still there, but it also has gas added to it. And then the bottom right kind of shows an example of one of the valve skids. And so there's multiple of those valve skids that go across the whole unit. So, you know, a lot of times on these units, you know, you're very space limited, and a lot of times you're trying to keep the unit running up to the last minute. So locating those for each burner and each elevation sometimes presents challenging. So it's a lot to lay out. And I guess, and the one thing we try to do is, you know, one of our strategies is to try to make this affordable. And to make this affordable, you know, a lot of boiler changes, a lot of pressure part changes sometimes make these projects not as economic anymore. So really we try to limit it to trying to get the gas supply in and try to get the gas burning with trying to use a lot of our existing boiler. All right, so our plants that retain coal, so basically we have still the same coal burner that we had before, but we've added gas to it now. And there's a couple of different designs that do this, and this is one that we selected for our plant. It adds gas down the middle, so if you look at the green section there shows where we're adding gas to the existing coal pipe, which would be in the gray. And here shows a flame on our tangential fired unit. And so on this unit here, there was no coal backup. So we were able to replace the existing coal nozzle with a dual gas nozzle arrangement. And I guess some differences in the flame, the natural gas flames tends to be more of a translucent with a blue and a yellowish orange to it, where a coal flame is going to be a really bright, strong orange flame. And so I guess just showing this slide here to show that, you know, if you had to start from scratch, the boilers would look quite a bit different. And primarily the difference would be in a lot of your reheat and your superheat sections. And so those would move forward in the boiler and also would change the geometry of them and the surface area to try to get that. But, you know, due to project constraints, trying to make it affordable, you know, a lot of those changes aren't possible. And so So we're stuck with a boiler that may not quite be optimized for gas firing. And so I guess here are some of the performance impacts that we've seen so far. And so since we don't necessarily have a boiler that's optimized for gas firing, we see a little bit of a drop in superheater and reheat steam temperatures. And usually at full load, it's not too bad. On some of the wall-fired units, it seems like when they get down towards the lower load, it starts dropping off more significantly, and they have to use some of their older flue gas recirculation fans to try to maintain those temperatures. But I guess going into it, that was expected. We've gone through, and one of the key things to do when converting one of these boilers is to go commission a design study to see the impacts of firing natural gas and just to see what changes will be needed before you actually get there. So we were actually had a forecast of low steam temperatures, and then we actually did have a little bit low. Boiler efficiency also drops off, but that's just inherently due to the fuel switch. Natural gas will be less efficiency with your boiler. And so that tends to be in about the 3 to 4% range on those. One of the things I didn't really anticipate till we actually got into it was you actually save a little bit on station service. So you're going to lose a little bit on boiler efficiency. That's going to hurt your gross number, but you get a little bit of it back in your net number with some station service by just not having to run your mills, your crushers, your conveyors, your ash handling systems. So that adds up. So your net heat rate doesn't take quite a big of a hit, but overall it was a decrease. So, but that ended up in some plants that totaled to be about 5 megawatts. One of the other advantages are these flames are very stable, and especially down towards the low end. So at some plants you're able to expand your operating range, and so the more flexibility you can give the unit, the more it helps the system reliability. You know, we talked about reliability in units that with on-off switches, and so, but this goes even further. If you have units that have more flexibility, you know, as we add emissions controls and all this, we tend to limit operational flexibility. You know, the SCRs have a minimum temperature and usually limit your lower load. So as you start retiring your smaller, older units, and you know you've got a lot of bigger units, you tend to have a lot of you know, higher minimum loads and restricted flexibility. So you got to find spinning reserves out of somewhere. And so if it's, you know, from a cheaper combined cycle, you may be not operating as economically as you could if you had a coal unit that had a lot of flexibility with it. And overall, the operating cost for the units, it tends to vary, depends on the plant and depends on the coal supply. We had one plant that actually decreased its operating, its dollars per megawatt's about 25%, and we had another one that actually increased about 17%. So it's not a straightforward gas is cheaper, coal is cheaper. It's a mix. It depends on where you can get your coal, and it also depends on the current gas prices. That was based on gas prices in the summer. So if you get that winter spike in gas prices, gas is going to be more expensive. And it also helps a lot on emissions. You know, this conversion was there primarily for mats to eliminate mercury, SO2, heavy metals. And so it does a good job on that because just inherently the fuel doesn't contain those. But some of the other emissions benefits are a lower NOx. We saw a drop about 60% NOx. And then the CO actually dropped 80+% in some cases. And so there's a balancing act there with the NOx and the CO, where you can, you know, stage and control flame temperature. So you can balance those a little bit. And then on the CO2, you know, just inherently with the lower carbon content, we saw in the mid-30s% reductions. And so, you know, you heard a lot earlier, I guess, 50% or half reductions with natural gas, but that was due more towards combined cycles, focusing on them where you get the lower carbon content and you get an increase in efficiency. Whereas with these boilers, you're just relying on carbon content. So I guess I went through those pretty quick there, but I guess in the end, that fits into our strategy of clean, reliable, safe, and affordable power. So I guess, anybody have any questions?